So in this video, I'll go right ahead and talk about vectors. I'm introducing vectors to you. This is Kisembo Academy. So what is a vector? In simple terms, a vector is simply a quantity that has both direction and magnitude, or has both magnitude and direction. And of course, when we look at the theory of vectors, we have things, examples of vector quantities. We have things like forces, velocity, acceleration, momentum. Now, to explain this in a more concrete detail will be in a physics video, where I'll get to explore these vectors in a more deeper sense. There is such a thing we call vector quantities and scalar quantities, and I've covered that in another video. Link is in the description below. The purpose of this is not to introduce vectors in that perspective, but in a mathematical perspective. So here, mathematically, vectors are represented using arrows. You can see this is a line segment and with an arrow. So it can either be represented like this, or it can either be represented like that. We see that this arrow indicates that this vector is running from position O to A, right? Like the same thing here, from point O to point A. That is how vectors are represented. So now, if a vector is moving from point O to point A, it can be written as OA with an arrow on top, signifying that it's moving from O to point A. Or you can simply call it OA with a tilt at the bottom. Or you can call this OA is A. And see, if you label vector OA as any letter A, you make sure you're supposed to write that letter with a tilt. That is just how we represent, that is the symbolic representation of vectors. A column vector is just a way of presenting vectors in using Cartesian coordinates. Let's think about it this way. If we are having a point A and a point B right there, so we have a line segment AB. So this line segment AB, to represent this as a column vector, it means that we're supposed to look at how this has shifted from this point to that point. And from here, we can assume, let's say this is 1 step, 2 steps, 3 steps, 4 steps, then 1 step, 2 steps, 3 steps, 4 steps. So this would mean that for me to move from point A to point B, I moved 1, 2, 3, 4 steps in the x direction. So for me, it would mean that I moved, AB is given by, I moved 4 steps in the x direction. Then I also moved 1, 2, 3, 4 steps in the y direction. So that is 4 steps in the y direction. And so I would represent it like that. So it would mean that vector AB is 4, 4. Now this kind of presentation of vector is what we call column vector. Now we have such a thing called a displacement vector. A displacement vector, for it moves from a specific point to another point. For example, we have point A right here. It's moving point A. If I'm to move from point A to point B, we have this right here. For me to move from point A to point B, let me draw a line segment right there. So for me to move from point A to point B, it would mean that I have to let me draw this right here like that. It means I'll have to move 1, 2, 3, 4 steps in the x direction, then move from here to there. For me to move from this point to that point, it would mean 1, 2, 3. It means for me to move from point A to point B, that is vector AB, it means that I moved 4 steps in the x direction and then 3 steps in the y direction. This is a column vector, but it is a displacement vector because this AB is with respect to a specific point. So this point A has been displaced. In other words, I have moved from point A to point B by taking these steps, 4 steps in the x direction and 3 steps in the y direction. And so this movement is what we are calling the displacement. And so this column vector is representing the displacement from point A to point B. So when we are dealing with displacement vectors, we are talking about displacement from a specific point. So if we are moving there, if I'm moving from A to B, this column vector represents the displacement from A to B, then maybe let's say I've started it maybe from this point. This is point 4, 1 to B. So I would simply find the number of steps in the x direction, then the number of steps in the y direction, and I would come up with my displacement vector form in the form of and that would be a displacement vector. It's showing the displacement from one point to another from a specific point. So in other words, when we're talking about displacement vector, we are simply talking about a displacement from a specific point. However, if this displacement is from the origin, when we are looking at our grid here, our Cartesian coordinates here, this is what we call the origin, 0, 0. So if our displacement is specifically from this origin, then our displacement vector is what we call a position vector. In other words, a position vector is when the displacement is from the origin, and our origin is this one at the point 0, 0. That is what we call our origin. If I may, for example, this is point A. For me to have moved from point A, I came from the origin. In fact, the coordinates of point A, which is 3, 5. This 3, 5 means that I moved 3 steps in the x direction, that is 1, 2, 3 in the x direction, and then 3 steps, and then 5 steps in 1, 2, 3, 4, 5. 3, 5. In other words, I moved 3 steps in the x direction and then 5 in the y direction to reach here. So that would mean that I'm counting these with respect to the origin O. So it means that a line segment from the origin, which I'm calling O, to the point A would give me a vector that I call OA. And this vector OA is what we are calling the position vector. In other words, a position vector is simply a displacement vector that is coming from the origin O. For example, if I told you that we have this coordinate, let's say this is coordinate 5, 1. This is coordinate, let's say this is 7, 3. This is coordinate B, this is coordinate C. And I asked you to find the position vector of point B. The position vector of point B is denoted as OB, and it's given as in the column form 5, 1. The position vector of C is given as OC, O meaning that it's coming from the origin O to where C is, so OC, which is given as 7, 3. So in other words, to find the position vector of a coordinate, or to find the position vector of a Cartesian point, the Cartesian coordinates and the position vector, they look the same. Same here. The Cartesian points and the position vector have the same digits, because these Cartesian points are always measured from the origin, and even our position vector is always measured from the origin, so that's why the figures will always look the same. Now, it's very important that you understand what I mean by position vector, because the concept of the position vector is going to be very key in its application when it comes to how we interpret questions moving forward. So still talking about basics, we need to explore something here. We have a diagram here, and we would like to find the vectors represented by these letters. We have a vector AB represented by letter A. We have BC represented by C. We have CD represented by D, then DE represented by E, then EA represented by F, and then EB represented by vector B. Now, we need to know that these letters, like you're seeing right here, are more like just representing where this is coming from to this is ending. They are more like names you've baptized. For example, this is A to B. For me to move from A to B, instead of calling it AB, I have decided to baptize it a name, and the name is A. If I move from B to C, I can just also call it just vector BC, but instead of just calling it BC, I have baptized it letter C. So that is what is going on here. And of course, as far as our vector notation is concerned, here we are supposed to put an arrow on top to show This arrow shows where the vector is coming from and where it's ending. If this is vector CD and the arrow is like that, it means it's coming from C moving to D. This is the vector notation, and it is this CD they are saying has been labeled as D. So they're asking us to find SC, vector SC. So this is how we would find SC right here. In terms of, we are supposed to find them in terms of these baptized names. So let's look at this. We have A, we have C. Now, meaning that I'm supposed to move from A to C. So what can I do? Where can I pass to move from A to C? For me to move from A to C, I can either move from A to B, then BC. That's an alternative route. Or I can move from A to E, E to B, then B to C. Or I can move from A to E, E to D, D to C. Any route, as long as my first letter is A and my last letter is C, I'm able to reach C. So if I'm to find SC, this is how I would do it. SC with the vector SC is going to be given by SC. For me to move from A to C, I can say it is AB plus BC. That's an alternative route. Take note here, that's route 1. And this would mean, what is AB? AB has been baptized as A. So it means that AB here is A plus BC. BC has been baptized C, and it's in that direction. So I would come here and write C. So I can say SC is given by that. And that's my answer. Or I can use an alternative route. For me to move from A to C, I can use this route, that route to reach C. So it means here that SC is going to be equal to AE. So I'll come here and say AE plus ED plus DC. Let me put arrows here. It's the same thing here. Let me maintain this as that. So what is AE? AE, now for me to move from A to E, it has been baptized as F. But the F is such that it is in that direction. We're supposed to take note of the direction of the arrow. The arrow says that vector F is moving from A to E. But for me, in my movement in SC, I moved from A to E. So if you're looking at this from A to E, moving from A to E means I moved in the opposite direction of vector F, because vector F starts from E to A. So because I moved in the negative direction, it means that AE in this case is going to be negative F. Then this is going to be ED, then that's going to be plus. What is ED? For me to move from E to D, ED is E. But E is defined by moving from D to E. That is as per the arrow. But since for me I'm moving in the opposite direction, this is going to become negative E plus DC. Now what is DC? For me to move to D to C is same as this. It's in the opposite of D, so it's going to become negative D. So definitely it means that SC is negative F minus E minus D. It's still giving us the same answer. This is an alternative route for me to move from A to C. So with that kind of simple illustration, I'm sure you can find AD, BE, CE. You can try those ones out. So that is basically how we find them. Now take note of this. I would like you to look, when we are defining the paths where we are supposed to pass. If you see my SC right here, A is the first letter here, and that same A is the first letter there. C is the last letter here, and that C is the last letter in my progression right there. It's the same thing here. A is the first letter here, and so A so happens to be the first letter right there. C is the last letter here, and C so happens to be the last letter of my working right here. So in other words, it's important that if you're talking about SC, A should be the first one and C should be the last one. Whatever is in the middle should be continuous. Same thing here. A is the first one, C is the last one. Whatever is in the middle here should be continuous. By continuous, I mean that the last letter here should be the first letter here. The last letter here should be the first letter here, and so on.